welcome back to my channel. If you like this video, please subscribe and like my video. I will be very appreciate. Okay, let's go back to our topic today. Last time we talked about dynamic and static motor starting analysis. And as you know, we didn't implement any starter or let's say uh, variable frequencies device last time on our motor, which we usually used on the real life on the industry like a factory or petrochemical or refinery factories. So as you know, we will have a lot of motor in the factories or refineries. So we are not afford start up and also stop frequently due to a different process in the chemical industry. But we are not afford to have this kind of like pulse voltage, uh, voltage go up and go down so frequently. So we usually have another starter in our motor and variable frequency device. It's a best solution. But we also have the other type of starter like auto transformer. So today we are going to compare different types of starter and without starter. So as you can see, I already have my single line diagram here. We have three different uh, we have three different motors here, but they all have the same uh, they are the same motor. They have the same nameplate. So what the difference is? I will go here. So here you can see the first motor. I didn't install any start device. Here you can see. So you can compare the differences on the plot after I do motor starting analysis. So the first motor I didn't install any starting device here, and it's a 200 kilowatt motor, just like the last video. If you haven't watched the last video, we talk about dynamic and static motor starting analysis, then you can probably go back and review a little bit. Okay, the second motor. So I choose auto transformer as my starting device. So you can control the scenario here. So let me just show you how to edit your control scenario. I will delete everything first and show you how to do that. So let me just input maybe two. It's two column here, and at the beginning, the tape was 65%, and I want it to go up to 80%, and then I want the third one go to 90% maybe. So that means when we use the auto transformer, how they will become the tap percentage to make the current to limit it the starting current, make it more flatting, but make the curve starting current curve more flat, but it will take longer time for the motor to go to a full load current. So I don't want to use the fix. I use ramp because I want the curve more smoothly. I cannot. So I want column 2 and column 3 use. Maybe 100%. So 65. And I edit the timeline. I go. So 80% on 1 second, and 2 seconds, 90%, and 3 seconds, 100%. And I will use fix RAM. So you can see the curve is more flat with this ramp control type. If you choose ramp, then the curve will be more smoothly. Okay, then yeah, you just choose start device and auto transformer. There are also other types of start device, but I don't want to introduce too much here. All I want to introduce is auto transformer and also variable frequency device. Then you press OK. And this one I will show you how to choose a variable frequency device. So let me just delete it first. Then you can see here it's a variable frequency device. Then you just click. You just put this element in your single line diagram. Then you add one bus here. Then after that, you have to run power flow. I will tell you why later. You run power flow. Okay, now you can see the full load current is 255.3 amps. Then you go to a variable frequency device and rating here. As we know, our motor is 200 horsepower, and our full load amps it's 250.3, and then here we just put default in this one loading, and then start device you have to edit it just like that time. Maybe this time I will add 3. Okay, let's start from the frequency percentage. So I will choose voltage per hertz. So maybe let's choose 600, not 6%. Then frequency percentage. Let's just choose from maybe 70 and 75 on 1 second, and maybe 85 on 2 seconds, and 95 on 3 seconds. Then go back to 100 on 4 seconds. Then we Same here, we'll choose ramp to make the curve more smoothly. Okay, it's a fix here. Then we are good. Then we press OK. Then we link the variable frequency device to the bus 2. Okay, then we are good here. Then we go to a motor station. Let's edit our study case here. We go to an event. I already create this event, but I create this event Q1 on 1 second, and as you can see, I start these 3 motor at the same time. Maybe I'll just show you how to edit this one. Okay, you edit this event, something will happen on 1 second. Then you edit this event action here. You start motor 2, and you start motor 4, and you start motor 6. Okay, now we are good. And I press, click OK. Now we can do our analyze. Let's do dynamic motor starting. Then let's see what the difference is between without a starter, with auto transformer starter, and with a variable frequency device. So let's do dynamic motor start. So as you can see, let's go to 1 second here. You can see we have a really low starting current on VFD2, which is really nice, because if you have low starting current, that means the bus 2, the voltage drop won't be very significantly. So you can see. Okay, let's now go to our plot manager. Something goes wrong on our motor 6. Let me check. Analyze. So I just found that I have some setting mistake in this variable frequency device. As you can see, let's go to a start device and control here. At the beginning, I set up this frequency it should be 0 because if you haven't started this motor, then the frequency should be 0. But I set up 70, then it will cause some problem. So remember, you have to initial this at 0. Then I go 75% frequency at 1 second, 85% frequency at 2 seconds, 95% frequency at 3 seconds, and I will choose all this control type as a ramp so that the waveform will be more smoothly. The curve will be more smoothly. Then I press OK. Then let's go to a dynamic motor starting. Okay, now we finished. Okay, now let's go to 1 second. So here it's starting current. So the starting current is around 18.7 compared to the other two. So the starting current for motor 2 without starter, motor 4 with auto transformer starter, and motor 6 with variable frequency device. You can see the starting current significantly decrease a lot. Then we go for the first one and second one, the current will decrease, and for a variable frequency device, the current will increase to its full load current. So as you can see, around like 6 seconds, motor 1 and motor 2 and motor 4 already go to a full load current, but motor 6 it's still isolate. So let's see the starting port. So let's see. So let's see our port manager here. As you can see, the starting current for close this one. As you can see, the speed and the current and the torque for this 3 motor. So as you can see, the speed, uh, the motor 6, it's the uh, most faster one to go to a full load speed here, and for the starting current, as you can see, the motor 2 without a starter, it has the uh, highest full load current, like 7 times. So the starting current it's 7 times. It's a 7 times full load current, as you can see here. But as you can see, the motor 6 with a variable frequency device, the starting current is really low, and for the motor torque, uh, it, the motor 6 has the most highest motor torque at the beginning, then go back to the normal. So in this plot, you can see our motor 6 uh, go to a full load current at around 4 seconds, but for motor 2, it's around like 4.5 seconds. Motor 2 is 4.5 seconds, and the motor 4 with auto transformer starter, it's around 5.5 seconds. So variable frequency device, it will make the motor has the lowest starting current, but also the fastest time to go to a full load current. So it's a best solution for a motor to install a variable frequency device, as you can see on this plot. So this is all about dynamic motor starting with different type of starter, as auto transformer starter and also variable frequency device. I hope you like video. I hope I can do a protection coordination video with ETAP next time. So I hope you enjoy it. If you like my video, please subscribe and give me a like. I will really appreciate. See you next time. Bye bye.